Hello everyone, my name is Vibhav Kumar. Today I am here to discuss about topic. Today I am here to discuss about Hall effect sensors under my video assignment of sensor and instrumentation. First of all, if you want to know about Hall effect sensor, then we have to know. If we want to learn about Hall effect sensor, first of all we have to learn what is Hall effect. It is difference across an electrical conductor that is traversed to that is तुम हंस क्यों रहे हो अच्छा ठीक that is transverse to an electric current in the conductor and to an applied magnetic field perpendicular to the current. Actually it was discovered by Edwin Hall that so it is named as Hall voltage. Now we will look about Hall effect sensor. Hall effect sensor. A Hall effect sensor is a transducer that varies its output voltage in response to a magnetic field. Hall effect sensors are used for proximity switching, positioning, speed detection and current sensing applications. In the figure you can see how it works. In the figure you can see the working of Hall effect sensor. Here is the Hall effect sensor. Now we will look for the working principle of Hall effect sensor. Hall effect sensor consists basically of thin piece of rectangular p-type semiconductor material such as gallium arsenide, indium antimonide or indium arsenide, passing a continuous current through itself. When the device is placed within a magnetic field, the magnetic flux lines exert a force on the semiconductor material which deflect the charge carriers, electron and holes to either side of the semiconductor slab. The movement of the charge carrier is a result of the magnetic force they experiencing passing through the semiconductor material. As these electrons and holes move sidewards, a potential difference is produced between the two sides of the semiconductor material by the buildup of these charge carriers. Then the movement of electrons through the semiconductor material is affected by the presence of an external magnetic field which is at right angles to it, and this effect is greater in a flat rectangular shaped material. The effect of generating a measurable voltage by using a magnetic field is called the Hall effect, after Edwin Hall, who discovered it back in the 1870s, with the basic physical principle underlying the Hall effect being Lorentz force. To generate a potential difference across the device, the magnetic flux line must be perpendicular to the flow of current and be of the correct polarity, generally a south pole. The Hall effect provides information regarding the type of magnetic field and magnitude of the magnetic field. For example, a south pole would cause the device to produce a voltage output while a north pole would have no effect. Okay, here you can see typical Hall effect switch. Hall effect sensors are available with either linear or digital outputs. The output signal for linear analog sensor is taken directly from the output of the operational amplifier, with the output voltage being directly proportional to the magnetic field passing through the Hall sensor. This output Hall voltage is given as VH is equal to RH in bracket I by T multiplied by B, where VH is the Hall voltage in volts, RH is the Hall effect coefficient, and I is the current flow through the sensor in amperes, T is the thickness of the sensor in mm, and B is the magnetic flux density in Teslas. Here you can see the graph of Hall effect in which output voltage versus magnetic flux density is drawn, and here you can see it is the saturation point of this graph. As we have seen, the application of Hall effect is proximity switching, positioning, speed detection and current sensing application. Now we will see the advantages of Hall effect. The advantages of Hall effect sensor are as follows. Production of an output voltage signal independent of the rate of the detection field. Hall effect sensors are not affected by ambient conditions such as dust, humidity and vibration, and are due to are insensitive to some ambient condition based on the principle that these sensor displays a constant flow of an electrical current, making their characteristic constant over time. Hall effect sensors do not have contact with neighboring mechanical parts, making these sensors strong and sensitive enough to detect movement. These sensors do not wear over time, thus maintain quality and unlimited use. Hall effect sensors are built from semiconductor material that display low carrier density, hence conductivity is smaller and their voltage is larger. Hall effect sensors depends on carrier mobility while eliminates any perturbations due to surface elements, thus making these conductors response reproducible and highly reliable. Now we will see the disadvantage of Hall effect. The Hall effect sensor does not have its disadvantage. The Hall effect sensor is not capable of measuring a current flow at a distance greater than 10 cm. However, use of magnet is strong enough to generate a magnetic field wide enough may make this possible. Hall effect sensor work on the principle of a magnetic field, making it possible for external magnetic fields to interfere with the with this and bias the measurement of a current flow. Temperature affects the electrical resistance of the element and mobility of majority carriers and also the sensitivity of Hall effect sensor. Even with well-centered electrodes, the offset voltage still presents as an output voltage in the absence of a magnetic field. An offset voltage occurs when there are physical inequalities and material non-uniformities. It can be as high as 100 millivolt for a 12 volt source. To solve this problem, an additional control electrode would need to be added, and through this a necessary current can be injected to obtain a null output when no magnetic field is present. Thank you.